what you don't know. Successfully lead a software project without tech expertise. Episode 5, Chapter 2, Building Software, The View from 30,000 Feet, Part 1.
What exactly is software? Software, code, is the programs, routines, and symbolic languages that control the functioning of hardware and direct its operation. From the definition itself, we can see there is a dependency on hardware. Ultimately, the work is done by the hardware. The software controls the hardware through its programs, routines, and symbolic languages. The symbolic languages are the way the programs and routines are expressed. 200 years ago, the very first calculating engines were developed. Computer hardware in its modern form has only been around for about 80 years. In 1944, the first programmable digital computer, the Mark I, was built. It was programmed in binary. The programmers of the day encoded solutions directly in the ones and zeros that controlled the operation of the machine. Programming languages developed shortly after that. Fortran in 1954, Lisp in 1958, and COBOL in 1959 were the first high-level, natural language-like programming languages, and all, in some form, are still in use today. ALGOL 60 in 1960 was a significant leap forward in programming language design that influenced all languages that have come after. In the 1960s and 70s, significant strides were made in the development of software paradigms, models of programming. Simula, CPL, and BCPL, which are forerunners of C and C++, Smalltalk for object orientation, and SQL for relational databases, were developed at that time. The 1980s introduced refinements of those paradigms in C++, Ada, Objective-C, for example. The Internet age ushered in languages built with the Internet in mind. Significantly, Python, Ruby, Java, JavaScript, oddly no relation to Java, and PHP were all introduced in the 1990s. Most SaaS products, networked apps in general, are built using some combination of the languages developed in those last few sets of languages. Or afterward. Languages have continued to be developed since the turn of the millennium. For example, Swift in 2014 is the new native language developed for iOS or Apple devices, and in its current version, 5.5 as of this writing, is available across all major platforms, Mac OS and iOS, Linux, and Windows. The software code is written in one or more of these high-order languages. It runs on computer systems that are a combination of hardware and system software as distinguished from application software. The system software is itself written in one or more of these high-order languages or other lower-level languages. Code must eventually specify in exceptionally minute detail exactly what the machine must do at each and every step. Just like the earliest ENIAC Mark I binary programs, ultimately the instructions become millions of sequences of operations, opening and closing some of the billions of logic gates in the hardware. A quote from Edsger Dijkstra, quote, "Programming will remain very difficult because once we've freed ourselves from the circumstantial cumbersomeness, we will find ourselves free to tackle the problems that are now well beyond our programming capacity." Close quote. Software projects are most often projects focused on developing application software. There are also system software projects that deliver basic functions at the systems level. For example, a systems program is invoked when your application needs to open a file and return the file contents. System software is highly specialized, though. Our focus is on the user or customer applications. According to Fred Brooks, more software projects have gone awry for lack of calendar time than for all other causes combined. Why would that be true? Well, estimating techniques are poorly developed and assume all will go well. Estimating techniques confuse effort with progress, the equivalence of men and months. Uncertain estimates lead to software managers who lack courteous stubbornness, a spine. Schedule progress is poorly monitored, and when schedule slippage occurs, it's natural to add manpower, see number 2. This has led to Brooks's law, quote, "Adding manpower to a late software project makes it later," close quote. So the first lesson is to treat all estimates of effort and schedule with extreme caution. They're probably made in good faith, but that doesn't make them right or even close. Building. If you're not going to be dominated by luck, then you have to understand what you are trying to accomplish. In the mind of the SaaS founder or their potential customer segment, there is more or less clear vision of the product, a tool that helps them accomplish something that is usually cast in terms of resolving a pain point or providing some lift or benefit to them or their business. The problem becomes how to get that vision into the heads of the developers of the product. The first part of the process is to define well enough what the product should do. This definition needs to be somewhat stable as work proceeds. You can imagine what would happen if you were to hire somebody to build a house for you, and after the foundation had been laid, you tell them that you want to change the floor plan. Well, as long as the new floor plan fits the laid foundation, you're probably safe-ish. But as time drags on, it becomes more difficult to change. There are many different ways of communicating the requirements, what the product should do. What is important is that, 1, all the requirements are described using the same process, and 2, once set and agreed to, the baseline set of requirements do not change, or changes are kept to a minimum and controlled. At any moment, all the stakeholders should be able to point to a body of information, known in the trade as documentation, and be able to see what is being built, how it is being built, when it is expected to be completed, and what completed means, approximately what it is going to cost, and approximately how long it should take. If you cannot lay your hands on that information, and it should be available in a convenient to find and easy to understand form, then your project is probably in trouble. The only question is, how deep is the trouble? What do we mean by trouble? Well, 1, a project that never finishes, or one that is canceled before it has been completed. 2, a project that is late, more than 30% late, often causing number 1. 3, a project that is over budget, more than 25%, also often causing number 1. 4, a project that has solved the wrong problem. You'd be surprised at how often this happens. Warning, the temptation will be to search for the problem this solution solves and then the people, customers who have it. This is a solution seeking a problem and is a ticket to bankruptcy, ruin, and despair. Don't do this. Not ever. 5, a project that solves the right problem and is completed in a reasonable time and budget, but works so badly or slowly or has so many bugs that is practically speaking unusable.
That ends Chapter 2, Building Software, the View from 30,000 Feet, Part 1. Join us next time for Episode 6, Part 2 of Chapter 2. That's it for me for you for now. Be careful out there. Bye.